Hi students, good morning. Okay, myself Professor Ishwaraj B. Patil. Today we'll see the DDCO Lab related concepts here. How to write a program for the Verilog code. Okay, with the help of the HDL language, means hardware descriptive language. Okay, this is what the integrated lab will be using here for the writing. But here the concepts I am using here the hardware descriptive language. Hardware descriptive language is the specialized computer language used for the formally describe what to describe the completely structure and behavior of the electronic circuit. What is that? Structure and behavior of the electronic circuit. Unlike the general purpose programming language like languages, HDL is the inherently used. Many everywhere you will be using include the notion and of the time and also concurrence also, which is the critical attributes of the hardware. Okay, which is this very important. This allows the designer to model, simulate and also verify the complex digital systems. What is that? This is the used for the digital designer to model, simulate and the verify the complex digital designs. Okay, which are used in the mainly what the microprocessor and the FGPs. Okay, basically the physical functional fabrications will be used. Okay, in order to avoid any errors in the program, and also we will be any repeatedly used programs which can be avoided with the help of the what is this Verilog code. Okay, Verilog code which will be used into textual description of the digital system design. What is that? Textual description of the digital system written using the with the help of the Verilog HDL syntax, which is in the IEEE standard language. Which is what that? IEEE standard language. Verilog resembles a C programming language. What is that? This resembles what the C programming language, which is used. This is also used in the electronics design automations, rarely widely used. Okay, mainly used. Okay, industries and the digital design and also verify the digital circuits with the various abstractions also. There are four different types of modeling in the Verilog. First one is the gate level modeling. Second one is what the data flow modeling. Third one is the behavioral model. Another one is the switch level modeling and transistor level modeling. First one will see the one by these levels of abstraction of the data flow the modeling of the Verilog code will provide the abstraction one by one. First we consider the gate level modeling. This is what sometimes called as what the structural modeling also. This is the lowest level of abstraction. We don't have any abstraction. We can say it's the whatever the things will be seen in the design, those gate names we can write directly as the where the design described in the with the help of the basic logic gates as the primitives and either and ಬರಬೇಕು or either are ಬರಬೇಕು not either night ಬರಬೇಕು not get ಬರಬೇಕು. This is the and also we can also we see in the some interconnections between the gate to gate, we calls the wire for them wire. If any connections between the and a gate to between the another gate, then those wires are connections are called as the wires also. And also we can also observe the specific components where the detailed understanding of the physical implementation necessary. First one consider the AND gate purpose. For writing the Verilog for the AND gate, we can see the and in the gate level modeling directly model with the inputs, output and the inputs combination. What is the output for the gate level AND gate? Two inputs are there, one output. Output is Y, inputs and A and B are there. Then the definitely I can writing the AND gate purpose, I'm using the AND itself as the AND gate keyword. Then the Y is the output, A and B are the inputs are there. Definitely the end of the model. This is what the how to write a Verilog code for the AND gate in the structural model or gate level modeling. Okay, we can see here structural model or gate level modeling. What are that one? Gate level, I'm using the directly gate as itself, name itself as the gate AND itself. Y is the input output, y A and B are the inputs are there. Okay, I hope you all following this one. Okay, next one is what the data flow modeling. Next one is what the data flow modeling. What is the data flow modeling? This is the style. Okay, describe the how data flow okay between the registers and also typically used for the combinational circuits, focusing on the function rather than the gate structure. Well, earlier we are observing focusing on what the gate structures. Instead of doing the gate structures, here we are concentrating on what the more concentrating on the functionality of those functionality of the gates, and it uses the continuous assignments statements like assign keyword I will be using, I will be using sometimes, and also wires I will be also will be using. Okay, for example, for writing of the Verilog code for the AND gate itself, model with the model within the model, the name of the model, and also we are writing the output and the inputs, A and B. Output is the AND gate plus A and B are the inputs, output is Y here. So that in the in this data flow modeling, one keyword I am using assign keyword. Assign Y is the output equals to A ampersand I am using, instead of using the gate name as the AND gate levels AND gate symbolic represent what operator representation is what the ampersand. So the A ampersand of B I will be using A ampersand of B. This is nothing but we calls what the writing of the code for the AND gate in the data flow model. Next we'll see the behavioral model. Next what's the behavioral model. In the behavioral model we have the highest level of abstraction. We can observe it designer to model the some systems behavior algorithmically without any specifying the exact hardware implementation. It uses the procedure system like if else statement, and also branches, some other loops also can use sometimes. Okay, within this array always keyword there I am writing the some input combination. Within that begin and begin and end within this we will be writing the some logic over there. For example, writing of the Verilog code for the AND gate in the form of the in the behavioral modeling as the model with the name as the gate and always keyword. Within that one A and B are the inputs. I am writing the begin keyword. Within the begin and end I am writing the, if the both inputs are high then only output is Y equals to high, otherwise it's what the 0, otherwise it's what the 0. Okay, B is 0 you are written there. This is all what the about the writing of the AND gate in the form of what the behavioral model. Just you observe it, always keyword I am using. Okay, and also begin and end. Within the begin and end brace I am writing the program. If else statement I am using, if the both inputs are high then only output is high, otherwise it is 0. Next is what the switch level modeling. What is the switch level modeling? Here the transistor or switch level models I am using. It is the lowest level of description of the in terms of the transistors or switches, okay, and also storage nodes, although it is used in the rarely used in the modern digital design system because of the complexity. This is what the complexity we are getting. That's what we will not use this kind of switch level modeling. Sometimes we can design if it is a smaller one then we can design, but thing is that you are nowadays the complex digital designs are there. This if you use the switch level modeling, that's the definitely you will get the complex over there, definitely. Okay, I'm revising now. Okay, there are four types of modeling are there. One is gate level modeling. In the gate level modeling, what is the directly AND gate are what are the gates I'm seeing there. I can use that one as the keyword itself, and Y is the input, output, A and B are the inputs. Okay, this is the next is what behavioral model. In the behavioral model is using the what the data flow model I am using the assign keyword. Next is the behavioral model, always keyword I am using here instead of okay assign keyword I was using what the in data flow model. Now I am using the assign always keyword. Within the always keyword I am writing the A and B are the inputs, begin A and B also. In the switch level model you can observe the transistors or switches. In the system digital design system can be designed with the in the level of what the transistor switches. This is what the somewhat rarely used and nowadays, and this is what the ruled out nowadays will not use because of the complex design digital designs I am using. Okay, we are having. Okay, this is all about the data flow model, structure model, or gate level modeling. Second one is the data flow model. Third one is what the behavior model. The fourth one is the switch level modeling. Okay, next write a program for the Verilog code for the AND gate with the help of the structural model. Only one within that one we'll see that one. You can see here AND y equals to y of ab. You can observe here, and also next is what the in the gate level modeling and gate used directly and itself. This is all about the writing the Verilog code for the AND gate for the entire data structural model. Now the data flow modeling is what the functionality of the continuity. Same I'm explaining one more time. Model AND gate and the output and inputs I'm defining, and also assign keyword I'm using y equals to a ampersand of b. Assign y equals to a ampersand of b. And the next is what the behavioral model. Just I'm using the behavioral model. I'm using the what is the registers y for the output purpose and input purpose always at the rate within that I and b and also within begin and end. Within that one I am writing the some logic over there if else with the help of the if else statement. For AND gate purpose I have written the if the both inputs are high then only output is high, otherwise it's 0. Okay, you can observe here. Just look at this one. Always keyword begin, a and b are there. I hope you all okay. This is all about the writing of the Verilog code for the AND gate in the form of the structure model, gate level model, or in even behavioral models. Next is what the test bench. How to write the test bench? What is the test bench? This is the input combination. This the test bench is in the Verilog model. It written in the specifically to simulate and verify the functionality of another design. This is not written in the hardware design. This is not synthesized in the hardware because it's only what we are checking the results, not the. It's not necessary to write in the synthesize in the synthesize in the hardware design. Okay, this is what we are doing. What the device under the test, and what we are doing the device under the test also, which is the synthesized into the actual it is not synthesized in the actual hardware. Okay, it's the generic input or simulate under test. We call the test vectors, and also we can see the gate level for AND gate purpose truth table. Here the input a input b output y 0 0 0 1 1 0 1 1. If the both inputs are 1 then only output is 1, otherwise it's for the 0. You can see in the truth table. That's with the help of this truth table only we are writing the what the test bench input combinations. What is the input combination? A and B are having the input combinations as the 0 0 0 1 1 0 1 1. Okay, these are the 4 combinations I am writing here, so that thereafter I can verify with the help of these 4 input combination output as what is the output for this one. Okay, this is all about the writing of the code for the AND gate with the help of the structural model or gate level modeling or behavioral model, and even combination, even the test bench also we are written. Okay, test bench combinations we have seen the inputs A and B are the 2 inputs are there, so that 0 0 combination is there. Okay, and 0 1 combination is there, 1 1 1 0 combination is there, 1 1 combination is also there, 0 0 0 1 1 0 1 1 combinations. There we will get the only the outputs both are 1, then only the output y is what the high, otherwise it is the 0. You can observe this one. Okay, this one is the how to run a simulation and also simulate this program. This is to be done in even the cadence tool also we can work, but in our lab we will be working on the tool only what the Xilinx 8.15. okay, this is all about the writing of the program into the different models. What is that all we have seen. Okay, thank you for the watching the videos, and also keep observing this one. Okay, And also we can see the some basic logic gates also. AND gate, here the AND gate purpose both inputs are high, then only output is high. Here the AND gate is having the two inputs A and B, output is y equals to A dot B. The operator is what? The dot is nothing but the multiplication. If the both inputs are 1, then only output is 1, otherwise it is 0. And also we can observe here the OR gate purpose. OR gate is having the inputs A and B and the output is y. OR gate is holding what the type of operation, it is the adding here. If the both any one input is 1, then only output is 1, otherwise 0. If the both inputs are 0, then the output is 0. If the any one input is high, then the output is high only in the OR gate. Similarly, in the NOT gate is having only one input A, y is the output. If the input is low, then the output is y is the output. Okay, then come to the NAND gate. NAND gate is the only one gate which is having the two inputs and the output is y. And also this is the complement of the AND gate. We can observe the bubble over there. This is the, we can see the truth table. We can verify the, compare the truth table of the AND gate and NOT gate. There we will get the complement of output of the okay, for the AND gate, for the NAND gate also. AND gate complements is what? The NAND. That's what the 0. Wherever the both inputs are high, then only output is high, we are getting in the AND gate. But in the NAND gate, both inputs are, any one input is, both inputs are high, then the output is low in this NAND gate. Similarly, the OR gate, we can observe this one is the output combination of the complement of the OR gate. This is the XOR gate. This is all about the XNOR gate also. These are the gates related to table and node. Okay, you can refer this one also. Okay, this is the writing of the program, Verilog program in the within a single program. Okay, I am writing the program, all the gates with the help of the data flow model. You can observe here the gate names with the, not the gate names, I am using the assign keyword here. Assign keyword, assign keyword, assign keyword for the each and every gate purpose. And also y is the instead of taking the y as the output, I have taken the AND out, OR out, NOT out, NAND out, NOR out, like this. Okay, just you see the model, all gates inputs A and B are there, output are defined as the AND out and R purpose R out, output as the NOT A out, and also output of the and NAND out and output of the NOR out, XNOR out. These are the outputs. Inputs are there A and B, outputs are these are things. Okay, just I'm writing the program for the Verilog code with the in the data flow model. That's what I used the assign keyword. That's what I used what the assign keyword. Assign keyword. All these Verilog codes using the assign keyword I am using within the continuous assignments as shown in this figure. Okay, that's the meaning of the assign keyword I am using. Assign AND out A ampersand of B, and also say assign Y R out A straight line of A straight line with the B for the OR gate purpose. Similarly, the